Okay, hi everybody. Welcome back once again to this channel. Thank you very much for joining us once again. If you're new to the channel, guys, please make sure you have just subscribed and turn on that notification bell so that you can be notified every time when you upload a new session. Okay. So we're gonna look at this quite very interesting question under your sequences and series. And without wasting any time, let's get into it. All right, so we are given to evaluate 1 over 4 plus 3 over 4 plus 1 over 6 plus 3 over 6 plus 5 over 6 plus 1 over 8 plus 3 over 8 plus 5 over 8 plus 7 over 8 plus dot 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 plus 1 over 50 plus 3 over 50 plus 5 over 50 plus 7 over 50 plus dot 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 up until 49 out of 50. Okay, so looking at this expression, you can see there's some sort of a sequence that is going on here, right? So it's a fraction, and you can see that in every part of each of these fractions, there's something common, right? Lowest common denominator is the same, right? With each of them. Okay, so basically what we can start by doing is that we can see some sort of a pattern to say let's try to simplify this so that we can see how far we go. We can take the lowest common denominator in these brackets, which is 4, then we have 1 plus 3. Okay, and we say plus, even in this case lowest common denominator is 6, then we have 1 plus 3 plus 5. Okay, then plus in this one, lowest common denominator is 8, then we have 1 plus 3 plus 5 plus 7. Okay, plus dot 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 plus. Here the lowest common denominator is 50. Okay, on the last term. Let me see how I can write these because of space. So here it's 50. Then we have 1 plus 3 plus 5 plus 7 plus dot 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 up until plus 49. Okay, so this sort of like simplify a bit. Okay, you can see that this last sum here, it's actually the last term. Okay, it's like the last term because it says plus dot 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 plus, but we can determine its value really by simply getting the sum on top. Okay, because you can see on top there's a series which is arithmetic series because you can see the difference is 2, the difference is 2, the difference is 2. Okay, so you can see that we can get the sum of the top, then we divide by 50 to actually get the value of that last term. Okay, so what we are doing is we are trying to evaluate that last one because we can see it's forming an arithmetic series because there are many terms we'll have to use the formula. But firstly, we have to find the number of terms that are being added there. Okay, so it's a Tn equals to a plus n minus 1d. Our last value there, it's 49, right? Remember, I need the sum of the numerator, guys. So it's 49. Our first term is 1, n minus 1, common difference 2. Okay, so when you solve for n here, it will be 49 minus 1, 48 divided by 2, 24 plus 1, and will be what? 25. So you are adding 25 terms then. Okay, then we can now get that sum of 25 terms. So Sn is equals to n over 2a plus last term. So sum of 25 terms, so it will be 25 divided by 2. Our a, it's 1. Our last term is 49. Then we can get the answer. Punch this on the calculator, then on the calculator, you get an answer of 625. So it means when you add the numerator on top there on the last term, they sum to 625. So we can rewrite that last term as 625, which is the sum of all those values on top divided by what? By 50. Okay. Okay, so now at this point, we sort of like reduce that whole last term expression. Okay, it's 625 over 50. Okay, These other first three terms, we can simply simplify them, right? Because you can easily add them. So it's 1 plus 3, it's 4 over 4, and 4 over 4, there it will be 1. Okay, plus, in this one, 1 plus 3 plus 5, that will be 9 over 6. So 9 over 6, it will be what? It will be 3 over 2. Okay, plus, there you have 1 plus 3 plus 5 plus 7. It's 16 divided by 8, which is basically 2. Then plus dot 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 plus 625 divided by 50, which can be reduced to 25 over 2. Okay, so you can see that we sort of like have a simplified sum now. Instead of that complicated one that we had, we sort of like at this point reduce it into something that is quite simplified. Perhaps our duty at this time is to check what kind of series is this. Is this arithmetic or geometric? Okay, so obviously it won't be geometric, because if it's a 3 over 2 divided by 1, it won't be same as 2 over 3 over 2. Okay, so you won't have common ratio there. So perhaps this might be an arithmetic series, but let's first check the common difference. So 3 over 2 minus 1, I get 1 over 2. Then I say 2 minus 3 over 2, I also get what? 1 over 2. Okay, so you can see this is a sum of what? Of arithmetic series. Okay, where the common difference is equals to what? It's 1 over 2. All right, but we do need to know the number of terms, because for us to evaluate this, to get the final answer of that sum, we need to use the formula Sn equals to n over 2a plus last term. So at this point, we just know a, which is our first term, it's 1. Our last term, we also know it is 25 over 2, but we don't have n, the number of terms. Okay, so we can go for the formula of Tn, a plus n minus 1d. Then we find the number of terms. Tn, last term, 25 out of 2. Our a, it's 1 plus n minus 1. You saw our common difference, it was 1 over 2. Okay. Then we can solve for n, right? So 25 over 2 minus 1, then we divide both sides by 1 over 2 or multiply by 2, then I get 23. Then if I add that 1 on negative 1, it's going to give me n equals to 24. Okay, so there are about 24 terms. Okay, so now we have our n, which is 24, our a, which is 1, our last term, which is 25 over 2. We can then use the formula for getting the sum and simply get the final answer for this expression. So Sn is equals to n over 2a plus last term. So it's sum of 24 terms in this case. Okay, so it's 24 over 2. Our a is 1. Our last term is 25 divided by 2. All right, so it's 24 over 2. 1 plus 25 over 2. All right, then we get the final answer, which is 162. Okay, so if we evaluate this, the final answer will be 162. Okay, I hope you find this helpful. It was a bit of a trick, guys, because you had to notice that you can simply take the lowest common denominator and stuff. And after that, on this part, lowest common denominator 50, then you get the sum of those on top. You had to notice that is an arithmetic series. You get the sum so that you get the answer of that whole expression, sort of like simplifying the whole expression into one, one term like that. Then you find the answer. Then this one can easily be added, after taking the lowest common denominator like that. Then you add on top like that, Then you realize it's creating a more simplified arithmetic series than you just simplified the sum. I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.